Controller, total controller. Like large.
Paul and I want to talk about foreign investments. We check which foreign countries were more or less profitable or risky, and we will try to answer the question of our exchange rates correlated with the index. In the first part, I want to talk about the motivation theory and the data and methodology. And in the second part, we will talk about the results and the conclusions. So, motivation. The question is, why are foreign investments important and so interesting for the European investors? For example, more than 67.2% of equity investment opportunities for European investors that are outside the Eurozone, and only 22.9% of the world bond market lie in the Eurozone. So when a European investor buys a non-euro denominated index, he is exposed to the exchange risk, and therefore it is important to research foreign investments for European investors. And what we try to do is that we try to quantify the new risk to which they are exposed. So now we must have to do a little bit of theory. The return of our position becomes two sums minus 1. The first sum is 1 plus the domestic return, this is called with RI, and the second sum is 1 plus the exchange return EI. And you can easily see, you can simplify it, and then you get that the return of the European investments is the sum of the domestic return plus the exchange return plus the product of the domestic return and the exchange return. The last term, the cross product, is very small in magnitude, so you can approximate it. And you can approximate it by the sum of the exchange, first that's the domestic return and the exchange return. How you can see that is that the variance of the return of the European investors is very complicated and long, and the last term is very small. It's the same case like we have in the return of the European investors, so we can usually approximate it by the sum of the variance of the first is the domestic return plus the variance of the exchange return plus 2 times the covariance of the domestic return and the exchange return. So now we come to the data and methodology. We used daily closing data for different indexes from the beginning of 2001 to the end of 2006, and the approximated number of observations on average is 1,516. We used the stock indexes for 15 countries, for example, Egypt, Hong Kong, Korea, and so on. The rest you can see on the slide. And for bond indexes, we use the countries Canada, Japan, Sweden, US, and the UK. Okay, what we do in our presentation first, we obtain the stock index in euro. Now the question is how you get the stock index in euro. You have only to multiply the stock index by the spot exchange rate. Then we calculate the annual returns using a 250-day sliding window, and we also calculate the weekly long returns. Okay, that was that. Now we come to a small result. Here you see a table of the mean returns of stock indexes. You have to see this is the first table and the second. To get a better overview, we make the highest value in each column red and the lowest value blue. In the first column and the second column, you can find the domestic mean returns, and how you can see that in the second table, you can see that the highest value you can find in Russia was 50 2.81%, and the lowest in the UK with 2.45%. Furthermore, you can recognize when you look to the developing countries like Brazil. You can see to the second one. And at Mexico and South Africa, the domestic mean returns are very high. And when you look to an industrial country like the USA, the domestic mean return is very low. But I must say that it's not very surprising.
This was the full 5-year period, right? From 2001 to the end.
Yeah.
Does this make sense to look at the whole period? I mean, for the European market, it was since 2001, it was sort of a bullish market, and it's a sideways market since 2004. But for the other countries, it makes sense to look at that big period. You see some time series there?
We'll look at it. Basically, we'll find out that there's basically like two parts of it. One, there's very low returns in all of the countries, and one, there's high returns in all the countries.
Okay, good.
So basically, you could like basically break it up into and be a better overview of what's going on.
Now we go to the third column. There you can find the exchange mean returns. What you see obviously that the most values are negative, and the highest value you can find in Australia on the negative, in Egypt with minus 10.99%. When you look now to the fourth column, you can see the total effect, and here you have the highest value you can find in Australia again, and in Egypt the negative value again. Here it's important to say that when you remember the approximation is only good if the exchange and the total effect, if the difference of that is really small. And when you look now to Brazil, there is a difference of 3.17%, so we can say that the approximation is not pretty good. But when you look to the USA, the difference is only 0.04%, and here you can say the approximation is very good, and so you must careful with the approximation. And the last term is the total return. Here you can see it's pretty high. You can see in Russia you have 46.55%, in the USA it's a negative value. Now we have the mean returns of bond indexes of the short maturity and the long maturity. What you can see is that all the highest value you can find in Sweden. And and it's a little bit different between short and long maturity. In the domestic mean returns, you can see that always the lowest value you can find in Japan, but it's not so many. Now we have some graphics. First, the US annual returns and Brazil. You can see that when you look to the first observation that the returns are negative, like in Brazil and other countries too, and then the returns are increasing. But if you look to the black one, the exchange return, it is increased not that fast as the other ones. Okay. Then we look to the short-term bond returns and to long-term bond returns, and here you can see that the total return and the exchange return is nearly the same. You can't see a big difference, but the domestic return is low, has a low magnitude of change. Yeah, and when you look at the long term, it's quite different to the short term, and there are a lot of drifts and it's going up, and it's especially the domestic return very up in the first section. Okay. That was probably.
Okay, so now we'll take a closer look at the composition of the variance.
What was the blue and what was the red one?
Sorry, the blue one was the domestic exchange, the black one was the exchange return, the blue one was the domestic return, and the red one was the total return.
Okay, so this is I also looked at various of the composition of the stocks. Important here to see is that in the stocks, most of the variance lies in the domestic side. Some countries like Switzerland, well, the domestic variance is greater than the variance of the total investment. There are some countries like Brazil, Canada, like Mexico, in which the weight of the exchange in the total variance is very big. That's you can see the total effect. That's the difference between basically the domestic variance and the total variance from the whole investment. So, for example, in Egypt, 57.4% of the risk or the variance comes from the exchange rate. Which was the risk this year? That's surpassingly, you can see right now. Also, you can see which how big the variance is, 2 times the variance in comparison to the total variance. The highest here would be in Canada, and the lowest in South Africa, which lowers the risk for the total investment. And at the end we have the mean. So on average, almost 76% of the whole the variance comes from the domestic returns, and only 24% from adding the exchange. In the bonds, especially the short maturity, most of the variance comes from exchange, because in this case the variance of the domestic returns is very low. And there's almost no variance, for example, in Japan. Only 0.46% of the whole variance comes from the domestic returns. And in the long term, well, for some reason Japan had a very volatile 2001, 2002. So the actual risk of the long-term bonds is very high in comparison to the exchange rate. But actually the exchange rate lowers the risk of the whole investment a lot in Japan. Okay, now to the risk measures. This is basically standard deviations of the domestic. Would be just the investment if you invest in the stock exchange at home. The exchange is just the standard deviation of the exchange rate. And we look at the correlation and the total risk. The lowest risk, domestic risk, was in Australia, and the highest was in Russia. Not surprisingly, had the highest mean. And the highest exchange risk was seen by Brazil, and the lowest by Denmark. Ireland actually is volatile in comparison to the euro. And the highest correlation was in Canada, and the lowest in Denmark, very negative. And we have most of the correlations are positive, some are negative. I will take a closer look at correlation because annual returns are not very good for correlation, because we'll just check out some plots afterwards. And the highest total risk is seen in Brazil. This is basically because of the correlation between the index and the exchange. And something the riskiest, and the less risky is Australia. Okay, so in the bonds, so it's not that interesting, but as we can see, the standard deviation of the short maturity bonds is very low. So like in this part, most of the risk comes from the exchange rate, which is a lot larger. And there's also seems to be a lot of correlation. All these annual return correlations are significant, but we'll take a look at it, a closer look at it in a bit. And in the long-term bonds, well, there's like the risk of the domestic risk and the exchange risk are comparable. They're not as different as in the short maturity, but the exchange rate still has a lot of weight on the risk of this. I will take a closer look at correlation. The problem with the correlation measure that we're doing basically is the same for all countries. Is that we take annual return. Well, it doesn't like there's the first relationships do not look to be linear. Second, there's lots of outliers. There are various modes. So, for example, you can fit a local linear polynomial regression, and you can see that the relation is not linear. So this is like the case with almost all the annual returns. You get very complex, very complicated structures.
It's exchange versus?
That's exchange versus stock returns in Brazil. Stock returns on the y-axis and on the
x-axis. This could be a cupola, this could be a lens. Interesting. Some those
And they're all like, in some cases, you just kind of, there's a lot of heteroscedasticity, so it's very hard to like, because to get out like a real correlation. I would be
show this to Enzo.
Actually,
You should. Yes, probably. Because maybe there's a reason for that. Where did you leave the country?
and
No, it's like it's exchange, but it's the same.
it's the same, but it's just the first half. So it's to show the difference between this is the first half, the first 3 years, 2.5 years, or the first half of the observations, and this is the second. Here, well, the first part
exchange returns relative to
stock returns. And this exchange dollar, euro, real.
Euro.
So, for example, here, well, you can see so there's a positive time period.
So the same time period.
And the second part, it's not even significant. So basically, the correlation that we got from the annual returns are untrusted. So we're going to look at weekly returns. And we returns a lot because of the data here and the actual mean measure than before. This is, for example, Brazil in the first half of the data. And in the second half, here we see there's what happens in the first half, usually, as a higher, the first half of the data, there's a higher correlation between the exchange returns and the stock returns. And in the second part, there's a smaller correlation, and this correlation, this difference is almost always significant in our cases. So for example, Switzerland has a negative correlation. And the reason why we calculate weekly log returns is because it's a lot easier to work with correlation with weekly log returns.
What's the reason for negative?
I don't
What
know.
does it mean economically that this depends is like in Brazil positively correlated?
Well, it means the exchange rate would be a hedge when it's negative. Like if you go to Switzerland and well, the exchange rate is bar is opposite to the investment, so it lowers the risk. And in Brazil, usually, for example, we can go back a little very fast. I'll do these returns, and we can see basically that the red returns, which are the total returns, are usually lower or higher than the domestic returns. I mean, there's more risk. If you take a look maybe at in Switzerland, maybe the exchange rate acts as a hedge because then your domestic risk will be lower. Your total risk will be lower than the domestic risk. Okay, so back to correlation. So in this table, interesting, for example, that Canada had the highest correlation before, at 60%, and in the weekly return, the highest correlation is in Brazil. And there are we have 3 non-significant correlations: UK, South Africa, and Hong Kong. In this part, you have the correlation in the first half of the data and the second half. And here, the difference is significant. In most of the cases, there's a significant difference between first half and second half of the data. It's a 95% confidence interval. In most of the cases, there is a significant reduction correlation between the exchange returns and the stock returns. Why this happens, I don't know. But I have to look at it. For bonds, basically in bonds, the correlation is almost always negative. Something interesting before, for example, Sweden had a negative correlation in the annual returns. Here it has a high positive correlation. And in the bonds, usually the correlation is negative, and the change is mostly non-significant. Like in the first half and second half, there's no significant changes. And also in the long maturity, correlation is negative in all of them, always significant. And the first and second half, in 3 of the 5 cases, there's no significant changes. So the correlation seems to be more stable on bond indexes. Oh, this should be conclusions and not motivations, right? And for stock indexes, domestic risk is usually stronger, but exchange risk has a significant effect. For bond indexes, exchange rate risk is usually comparably stronger, to domestic risk. Non-OECD countries exceed the largest domestic exchange and total risk for European investors, and they also provide the largest returns, economically sound. And for stock indexes, correlation with the exchange rate is usually positive, and we just saw. For bond indexes, the opposite occurs. And for stock indexes, there's a significant decrease in correlation with the exchange rate in the first and the second one. As a learning experience, you have to be careful with correlation because I could lead to me. So, these are references. There's some portfolio book, a paper we use for some ideas, and for SFM book, and a few other methods.
Questions?
Can you say a few words about so-called quant options? What was the motivation for this project?
On how options? Well, basically, I don't see how it was the motivation for the project, because basically we were looking at the correlation and how the addition of exchange risk or the exchange rate changes our returns. And basically, the options, I believe they're like
Quant options.
quant options.
Quant options.
No,
I think I told you.
Yes, but
I don't know that. Yes.
Yeah, you told me, but basically, looking at the question in the
Basically, you ignored it.
well, what I got from Shimon is basically this quantum, the exchange. You can have a positive, you can exercise it in your domestic currency, but then you can lose money because the exchange rate makes you like has a negative effect. So basically, just like looking at this, you can see that sometimes, for example, in the case of the USA, you can have a negative return because of the exchange rate, and then yes, it has to. You can extrapolate it if you know what to extrapolate.